All right, review number 3. We are going to go right through these. Guys, please, I can't stress to you enough. You got to try these first. If you haven't done it yet, you got to try them. You don't know if you know it. You can't just go through and watch this. You really need to try them first and see how you do. You can, at this point, I would try it, pause the video, see if you, and then watch the solution. Then go to number 2, try it, watch the solution, and go ahead and do that if you haven't done it already. All right, so here we go. Question 1, just looking at decreasing. Decreasing is when the function goes down. So see, this function already going down. It's a downward slope. Think of it like slope, going down, down, up. That's what this is doing. It's going down, up, down. So it's decreasing, increasing, decreasing. So where is it decreasing? It's decreasing here to here, and it's decreasing from here to here. So negative infinity, this is negative infinity over here for an x value, and it decreases down to right here, which looks like about negative 2. So negative infinity to negative 2, and from 2 to infinity, right there. Choice C. Which describes the end behavior. Well, we're gonna need our calculator here, and I already did it for you. I already did it ahead of time to save time on your video. I know you don't have a calculator at home, so what you're gonna do here before I give you the answer is take a look here. Use my calculator if you don't have one. So there's the function. Let's go to the graph. Take a look. All right. So taking a look at this graph, see if you can do it. All right. You have the graph going up forever, and down forever, right? Okay, so it can't be positive, positive. It can't be negative, negative. All right, so it's got to be one of. If it was negative, negative, it would be like an M. If it was positive, positive, it would be like a W. So it's not going to be either one of these. It's got to be one of these. So as x goes to negative infinity, as x goes this way, it goes down. So y approaches negative infinity. So as x goes to negative infinity, y approaches negative infinity. That is correct right here. And as x approaches infinity, y approaches infinity, because as it goes to the right, it goes up. So left and down is negative infinity, negative infinity. Right and up is positive infinity, positive infinity. It is choice A. This one's backwards. Choice B is backwards. All right, bye-bye calculator. All right, number 3, restrictions. Well, to see the restrictions, you need to factor. I hope we know how to factor by now. Take out a 2x down here. 2x, 3x minus 5. So I have a restriction on 0. 2x cannot equal 0. Divide by 2. X cannot equal 0. So it's either A, B, or C. It can't be D. And 3x minus 5. So 3x minus 5 equals 0. Add 5. Divide by 3. So you get 5/3. 5/3 and 0. X can't be 5/3. X can't be 0. That's choice C. Factor completely. All right, come on, guys. We got to know this by now. Take out a 2. Take out an x. 2x. 3x squared plus 9x minus 12. Is that right? What am I doing? Oh, that's because we need to take out a 6. Oh, so I'm yelling at you guys. We got to take out a 6x. 6x. X squared plus 3x minus 4. There we go. 6x. But see how I knew I had it wrong? Because I still had common factors there. Kind of glad I did that, actually. All right, so there we go. 4x minus 1x is 3x. There we go. All right. This one's a little trickier, obviously. No common factor this time. It's got to be 5x times 1x, because that's going to get you 5x squared. How do you get 6? It's either 6 times 1 or 3 times 2. All right. I don't know what it's going to be. It's kind of a guess and check. So you got options. How about 3 here and 2 here? Does that work? Yes, it does. I have 3x here, and I have 10x. Look at that. 3x and 10x, and of course that'll give me 7x. Positive, negative, and positive, negative. I'm kind of going quick because we should know this by now. You know, maybe you didn't get it, but you at least should have the idea, okay? All right, simplify each, include all restrictions. So simplify, just factoring. Factoring, canceling out, right? Oh, I'm sorry, I said the C word. Reducing to 1 or negative 1. All right, so we have x plus 6, x minus 6. We have x plus 6, x minus 1. Yep, because that's 5. Yep, that works. And, okay, x plus 6 reduces to 1, and it leaves us with x minus 6 over x minus 1. That's it. So now I have a common factor of 7x here. And that'll be x minus 3. And then I have a common factor of x squared times 3 minus x. And of course, let's see, I'm going to make x squared x times x, if you don't mind. X squared is x times x. And this reduces to negative 1. Hopefully you see that. And I can reduce one of these x's to 1. So I'm left with negative 7 over x. Negative 7 over x. Now, don't forget about your restrictions. Here, x cannot equal negative 6, and it can't equal 1. Here, x cannot equal 0 and 3. Positive 3. All right, moving on. Number 6. Use an algebraic method to solve for x. So algebraic method going to have to be the quadratic formula here. So because it's not going to be factorable. So we're going to have to go x equals negative b, which is 6, plus minus b squared is going to be 36 minus 4ac all over 2a, 2 times 3. So that's going to be 6 plus minus, it comes out to be radical 12 over 6. Don't reduce those, because it would have to divide over here as well. You want to break this up. 6 plus radical 12 over 6, 6 minus radical 12 over 6. And that's going to be 1.58 or 0.42. Okay, so there is the, then you could verify with the calculator, on the calculator, you know, you would type in your function here, okay? Type in your function and then do the 0 command. Okay, because if it's equal to 0, you want the 0 command to get the x-intercepts, left bound, right bound, guess. I'm not going to do that in the video, but that's what you would do to check yourself if you had to do it on a test. All right, so simplify, include instructions. Out, we're subtracting, so we need a common denominator. So here I need x plus 4, x minus 4. All right, this is going to be x plus 4, x plus 2. All right, so what am I missing here? Well, I have x plus 4. I need x plus 2 here. So I got to put an x plus 2 up there. I need an x minus 4 here. So I'm going to have to go x minus 4 here. All right, so I have x plus 2 minus x plus, oh, I'm sorry. Messing up here. X plus 2. Now look at this guy. This negative 3 here has to get distributed. So it's going to be minus 3x plus 12. Minus 3x plus 12 over x plus 4, x minus 4, x plus 2. I better simplify this. This is 4x plus 10. No, plus 14. Okay, so I can mess up a little bit more here, right? Okay, so that's negative 2x plus 14 over x plus 4, x minus 4, x plus 2. And that's it. Just combine your like terms. Combine your like terms on top, and then denominator stays the same. All right, here we have, now we're multiplying. So multiplying, remember, you don't need common denominators. You need to factor everything. So it's going to be 9 minus x squared. That's 3 plus x. 3 minus x. And then I have x plus 6, x plus 2. And then I have x times 6 plus x. And 5x minus 3. Common factor, guys. I know some of you are not strong on those common factors. Got to look for those common factors. You have it here, you don't have it here. All right. 6 plus x and x plus 6, that's just 1. Because you're allowed to switch the order of addition when you have addition, commutative property, not subtraction. So x minus 3, 3 minus x, that's negative 1. And that looks like all we can do here. So we have a negative x, final answer, negative x, 3 plus x, over 5x plus 2. That's all we can do. Can't reduce more than that. Division, we're going to factor everything. M plus 3, M minus 3. This is M times M. And then keep, switch, flip, right? So change that to multiplication. Flip. Common factor, 2M. M plus 3. And all I can do is go M plus 3 is 1. And it looks like that's it. I have 10 m minus 3 over 2m to the third power. That's it. Over 2m to the third power. I'm sorry, 10 over 2. 10 over 2 is 5 over 1. So I actually have 5m minus 3 over m to the third. 5m minus 3 over m to the third. All right. This one here, I'm going to erase this, and just because I need more room for this here. So we have, there's parentheses here. You have to do the top and the bottoms, or to subtract the top, or add the bottom, and then you're going to divide. So, all right, so we need common denominator. I need x over 4 minus 16 over x. Well, this needs a 4, so that needs a 4. That needs an x. That needs an x. All right, and then I need a x here. That means I need an x here. I need a 3 here. I need a 3 here. Okay, so this is going to be x squared minus 11x over 3x plus 24 over 3x. Okay, now I'm ready to combine. So I have x squared minus 64 over 4x times, because we're going to, it's dividing, right? And then the 3x is going to go on top because we're going to flip that, and it's going to be x squared minus 11x plus 24. All right, so I think that works good. Yes, it does. Now I'm ready to factor x plus 8, x minus 8, 4x, 3x, x minus 8, x minus 3. All right. That's 1, and the x's. The x's reduced to 1 as well. So I am left with, I'm just going to go up here with my answer, I am left with 3 times x plus 8 over 4 times x minus 3. That would be it. All right. Next page. Page 3, we're moving on. We're getting there. Synthetic division. Oh, good. This is easy. X plus 3, got to make sure that's equal to 0. So I have x, actually x would equal negative 3. That's what we have to use for our synthetic division. Do I skip any terms? 3, 2, 1. Nope. So 5, 8. Make sure you don't skip any variables. Any terms. Okay, it's down to 1, and 5, and then negative 15, and then negative 7. That's 21. That's negative 2. Adding down. This is 6, and then we have a 14 left over. Is that what I got? That's what I got. Okay, so there we go. Now, we started with a third degree. Now we're on second degree. This is 5x squared. So your answer is 5x squared minus 7x minus 2. And then this is your remainder. It didn't come out to be 0. That means you have a remainder. Plus 14 over whatever you were dividing by, which was x plus 3. So this is how you would write your final answer with a remainder. Those are our part 1 and 2 type questions you might see on the test. How about our part 3 and 4 type questions? All right, so for number 9, we're going to solve each equation for x. Part A is one of those rational equations that contains more than one variable. So we want to solve for x because we don't have a common denominator. We want to make sure we get one. So we have x, y, z. That means x, y, z has to be our common denominator. So we have to multiply this by y, z. That means the top needs to be multiplied by y, z. This needs to be multiplied by x, z, because you already have the y. So then x, z here. And this gets multiplied by x, y. So x, y up here. All right, so now we have x, y, z, x, y, z, x, y, z. So I can cancel out the common denominators. That leaves me with y, z plus x, z equals x, y. Okay, now it looks kind of weird, but think about what you're actually trying to do. You're solving for x. That means you want to get x by itself. Here's x right here, and here's x right here. We need to get those on the same side of the equation. So I'm going to subtract xz. That's going to leave me with yz over on this side. And then a lot of students think you could put these together and it'd be like yz because the x's would subtract and give you 0. That's not the case. It's the term xy minus the term xz. They are not like terms. So it's xy minus xz. That's all you can do there. So I have yz equals xy minus xz. I do have the x all on the same side of the equation though, right? Now I can factor out an x. I have a common factor here. X times y minus z. I just took out the common factor of x equals yz. And then I'm solving for x, so I want to get x by itself. This is x times, right? X times y minus z. So since it's multiplication, I'm going to divide by y minus z. Whatever you do to the one side, you do it to the other. And that is your answer. This cancels out, leaves me with x equals this. yz over y minus z. So x equals yz over y minus z. Factor x minus 2, x minus 3. This is, so let me get rid of that. This is 3, x minus 2, and this is 3, x minus 3. So what are we missing? All right, I have a 3, a 3. I need a 3 here, so I need a 3 here. That's easy. I need an x minus 3 here. I need an x minus 3 here. I need an x minus 2 here. I need an x minus 2 here. All right, so denominator's gone. Got an extra line there. All right, so 3x minus 24 plus x squared minus 3x equals 5x minus 10. So I have x squared minus 5x, I'm just kind of doing this here all together, minus 14 equals 0. I just got to bring these to this side here. If you did the work, you would see what happened there. So x is 7 and negative 2. 7 and negative 2. And those are not restrictions because my restrictions are 2 and 3. And negative 2 and 7 are good. So negative 2 and 7 are good. Write a function in factored form that could create each. All right, well, watch for signs of multiplicity. That's the bounce or the wiggle. Okay, bounce or wiggle. Bounce is multiplicity of 2, wiggle is multiplicity of 3 or more. So there's no bouncing or wiggling here. This is straightforward. Boom, boom, boom. Look for my x-intercepts. Looks like negative 3, negative 5, negative 5, negative 3, and 1. So my factors f of x would equal x plus 5, x plus 3, x minus 1. Now we know there could be a number in front, but we're not worried about that. We just said that could graph as. So we're not worried about maybe there's a vertical stretch or what the vertical stretch is. That's why the y-axis doesn't have a scale. Okay? So this could graph as this. F of x equals. Now this one's a little trickier. We have negative 2, and we have 1, and we have 1, 2, 3. All right, so negative 1, so we have x plus 2, we have x minus 1, and we have x minus 3. I think that's the easy part, but we're not done. Because we have the bounce at negative 2, see how it doesn't go through negative 2, it bounces off of negative 2? That's a multiplicity of 2. That means there's like 2 x minus 2's there, or x plus 2's. So we're going to square the x plus 2. We have it goes through the 1, so the x minus 1's good the way it is. But then again, it bounces off of this 3 here, so this x minus 3 also has a multiplicity of 2. It is a 5th degree polynomial with only 3 x-intercepts. So here is the factored form that could graph as this. Okay? Solve for x. All right, so I'm going to get everything equal to 0. X to the third minus 6x squared. I'm going to take away 3x and add 13 to both sides. You do that over here, you get minus 4x, and you get plus 24. So I'm going to factor by equals 0. So now I'm going to factor by grouping. X squared, x minus 6. And then I could take out a negative 4 and get x minus 6. X squared minus 4, x minus 6, x plus 2, x minus 2, x minus 6, and therefore x would equal negative 2, 2, and 6. So my solution set would be negative 2, 2, 6. 3 possible solutions for this equation. All right, last page, we're rolling here. Mrs. Brown, these work problems. Mrs. Brown could paint 3 average size rooms in 8 hours. So her rate would be 3 to 8. Mrs. Brown is a 3 to 8. Her son would need 12 hours to do the same thing. So her son can paint 3 in 12 hours. If they work together, adding, how long will it take to paint 6 rooms? 6 rooms in how many hours? So working together, add their rates together. 6 rooms in how many hours? Okay, so that's going to be, we're going to go 24. So we're going to go times 2 here, times 3 here, and then we need our x as well. And this is going to be times 24 because we already have the x. All right, so this is going to give us what? It's going to give us 9x plus 6x equals equals 144, and then 15x equals 144, and then divide by 15. So x is going to be 9.6. So it'll take about 9.6 hours, 9.6 hours to, if they work together, 9.6 hours. Now I want to think about that for a second. 0.6 hours, what is that? 6.6 hours. So that's 6 out of 10. So if you switch it and figure out how many minutes that would be, you could actually do that. So you could do 0.6 times 60 to figure out how many minutes that would be. Okay, so 0.6 times 60 minutes in an hour, so that would be 36 minutes. So 9 hours, 36 minutes. That's how long it would take if you talked about in terms of time. All right, and then what do we have here? Kim, we got quick. So Kim can complete a job in 6 weeks, and the same job would take Kevin 10 weeks. So Kim can do one job in 6 weeks, and Kevin can do one job in 10 weeks. How long would it take Derek working alone? So we have Derek, we have a third person. We don't know how long it takes him. They work together, so we're adding, and all three can complete the job in 2 weeks. So one job in 2 weeks. All right, so our common denominator, 10, 20, let's go to 30x. So times 3x times 5x times 30, and I'm going to 30x, right? So 15x. All right, common denominator, so I have 5x plus 3x plus 30 equals 15x. So I have 30 equals 7x, and then divided by 7. Again, it's not a nice number, but it is 30 divided by 7. We're going to do it this way. 30 over 7, it's an acceptable answer, but I want to kind of show you how to do it when we talk about actual weeks, right? How long? Well, 30 divided by 7 is 4, which is 28, and there's a remainder of 2, right? 4 remainder 2. For what? Well, we're talking about weeks. So 4 weeks and 2 sevenths. 2 sevenths of a week. How many days is that? What's 2 sevenths of a week? 2 days, right? So 4 weeks, 2 days. It would take 4 weeks and 2 days for them to, 4 weeks and 2 days if Derek, working alone, did it. It would take 4 weeks and 2 days. All right, last one, and then I'll have you on your way. All right, given the following function, answer the following: what are the x-intercepts? Okay, so what we're going to do here is we are going to factor, and to factor, we are going to take out an x squared here. So we're going to have, I'm just going to do it, I'm going to do it right here. So we have x squared as a common factor, and that's going to leave x squared plus x minus 6. And then that can be factored further: x squared, x plus 3, x minus 2. Okay, so now that is the factored form: x squared, x plus 3, x minus 2. So what are the x-intercepts? Well, x squared equals 0 is going to give you a 0. X plus 3 equals 0 is going to give you negative 3. And x minus 2 equals 0 is going to give you positive 2. So those are my x-intercepts. Remember, just set the factors equal to 0. Determine algebraically if the function is even, odd, or neither. Even, odd, or neither. Okay, so in order to do that, we have f of x. We have f of x, and that's x to the 4th plus x to the 3rd minus 6x squared. You need to do f of negative x, and you have to do negative f of x. So let's do both of those. Negative f of x. All right, so f of negative x just means plug in negative x. Plug in negative x for x. So it's going to be negative x to the 4th plus negative x to the 3rd minus 6 times negative x squared. So this is going to be negative x to the 4th. Remember, if you're raising to an even exponent, it becomes positive. So this is going to be just plain old x to the 4th. Negative x to the 3rd is going to be negative x to the 3rd. And negative 6x squared, because that negative just squares and becomes positive. But the negative's already here that's not being squared, so the negative 6 remains. So, does f of negative x equal f of x? It does not, because the x to the third becomes negative. So that is a slight difference there. So it is not an even function. It is not an even function. And we got to do negative f of x now. Just going to do that below here. So you just do negative of the whole function. X to the fourth plus x to the third minus 6x squared. We do the negative of that. So basically change all the signs. That becomes negative x to the fourth minus x to the third plus 6x squared. Does this match the f of negative x? Do those match? No, they don't. So it's not odd either. So this is neither even nor odd. If this one, if these circled one, if those matched, you have an odd function. If these match, do a different color. If these match, you have an even function. So, in summary, to be even, f of x equals f of negative x. To be odd, f of negative x equals negative f of x. Negative f of x. All right, so this is neither, and you could show y. All right, and this shows y as well. Find the average rate of change over the interval negative 2 to 5. All right, so it's q. Oh, should have said f instead. I should have said q. Q of, that's a g. So it's q of 5 minus q of negative 2 over 5 minus negative 2. Remember, it's f of b minus f of a over b minus a. All right, so q of 5. We got to do q of 5. Keep writing g. Okay, so we got to do q of 5. Q of 5 is going to be 5 to the fourth plus 5 to the third minus 6 times 5 squared. All right, so that's going to be 5 times 5 is 25 times 5 is 125 times 5 is 625. This is 625 plus 125. And then this is going to be 25 times 6, which is 150, minus 150. So we have 750 minus 150 is 600. So this comes out to be 600. So that's q of 5. It's going to be 600 minus something. And then 5 minus negative 2 is 7. All right, so now I'm just going to erase this because I'm running out of room. I could extend the page, but... All right, so now we're going to do q of negative 2. And that's going to be negative 2 to the fourth plus negative 2 to the third minus 6 times negative 2 squared. Okay. Negative 2 to the fourth is 16. Negative 2 to the third is negative 8. And negative 2 squared is 4 times a negative 6 is negative 24. So I have 16 minus 32. I have negative 16. So I have 600 minus negative 16. That's 616. 616 divided by 7 comes out to be 88. So the average rate of change over the interval negative 2 to 5 for this function here is a positive 88. It's a very steep slope. All right, so I hope you learned something from this video, and I will see you for the quiz tomorrow.